Okay, the line drawn from a point that divides one side of a triangle in a certain ratio, there it is there. The line is drawn from a point that divides one side of the triangle certain relation to the point that divides the second side in the same ratio. So make it look like it's sort of the same ratio, like that's a little bit of that and that's a little bit of that. It's not beautifully scaled, is it? The line that joins them, it says what? It's parallel, so this line, it says it's parallel to that line. How am I going to do that? They're going to give us some details. Because if you first look at this now, you go, I don't have a clue what I'm doing, I don't know what's going on, the whole thing. So, in triangle OAB, in that triangle, from O to A is called A. Why? Because they wanted to. Or does it matter if you called it something else? No. From O to B is called B. So what do we got? We got that. C and D are points on OA and OB respectively. So they said make that C and D, but they're giving the diagram anyway. Such that, now here's the big one. Such that what? What's it say? OC equals HOA. What do we mean by that? OC, let's go different colours. Got one here somewhere. Where's my red cap? There it is. OC is a part of OA. Part of OA. Does that make sense? Why do they use H and K? Think about this the other day. They used A, B's and C's for constants on quadratic formula and everything like that. We use X and Y for everything else, and Z for everything else possible. So you get the point, you start running out of letters. So they decided to go H and K for this, pretty common. And when we're doing for any do with vectors, you're going to see H's and K's, and then you get lambdas and all Greek letters and all sorts of stuff. So a part of that. So OC is a part of OA. That there is a part of OA. That's all it says. What's the next part say? OD is a part of, did they use K? H. Oh, it's got to be the same part. Sometimes you want a different part. This one is a part of OB. In the same part. So if we had half of OA, where would it be? The midpoint. So if I had a half of OA, I'm in the midpoint. If I had a quarter of OA, where am I? Down here somewhere. If I had a quarter for that one, I'd also have how much for this one? Quarter of that one. Would it look like it's parallel? Rough as bags, but it looks like it's parallel. If I went halfway, would it look like it's parallel? Yeah. So before you start it, you know it's true. You've got to prove it's true. So just because you know something doesn't make it true. Yeah. Sometimes you know for a long time and then you figure out later it's true. So this one is going to be, across the areas, H of OB. Let's get that out of the way. That's it. All the question is just setting it up and talking about it. Prove, lots of words, what it does. CD is parallel to, you okay with the two lines are parallel? We did enough of that, didn't we, before? CD is parallel to AB. How am I going to do that? I want the vector CD and I want the vector AB. I want the vector CD and I want the vector AB. I'm going to get them. How do I get the vector CD? How do I go from C to D? I could do this if I wanted to. I could go up there, across there and back down there. That's the long way. Or I can just go there and I can go across there. So any two vectors any time. Oh, I feel like saying, if I want to fly from Canberra to, I don't know, where's somewhere with D? Darwin. I want to fly from Canberra to Darwin and in the middle I stopped in at O. Where's an O?
Australia.
Wow. Somewhere in Australia. All I want to do is go from C to D. I'm going to fly to some other point and get there. So I actually went from there to there, but there's the actual vector across there. O for Australia. So what have I got? I'm going to write it properly for once. So to go from C to D, we've got to go from C to O. What do I go next? I'm going to go from A to D. So how do I go from C to O? C to O is the reverse of what that is. So it's actually minus H O A. Make sense? How do I go from O to D? H of OB. So we've got minus H times by something. What have we got times by? What's OA? Right at the beginning it said that. Let A equal OA. So that's why I've written it over here. That one right up there. So I've got that's A, vector A. So I don't have to write all the letters, I can shortcut it, but for the moment we're writing everything down. This one's H times OB. What's OB? From there to there was called B. So right at the beginning we meant let B equal OB. So I got HB. What have I really got? I could write the other way. A lot of people don't like writing the negatives first, so they got HB minus HA. Easy. Now what does it say we'll get approved? That that's parallel to that. Now I know now that this vector here is HB minus HA. See why we can't just go through this in minutes? You will, you get the hang of it, and then it puts more twists onto it. So this, how much can we shortcut going from A to B? Could have just written this. Minus A plus B. Do I have to write this down? I'm going to get AO plus OB. By the way, of course, that's been split apart into those, and there's just O in the middle. So what's AO? From A to O is the opposite of O to A. So that's minus A. What's this one? Plus B. Right the other way around, most people do, but you don't have to. What can you tell me about those two vectors? There's vector AB, and there's vector CD. It's the same vector. So this vector is H times bigger than that. So if I took out H as a common factor, I've got B minus A, and what's what I could write here? It's H times by B minus A is AB. So CD is a certain number times AB. So if I had a vector here and say that was AB, and I just said to you that, I don't know, what was it? CD? CD was twice as long as AB. Are they parallel? Yeah. So they are parallel. You can go as simple as therefore they are parallel. So CD and AB are what? Parallel. Done.